a deeper understanding of the universe in which that understanding gets embedded. And you realize that you only understood a small part of a larger whole.
When the Big Bang occurred 14 billion years ago, the universe as we know it began from a single point, one that was infinitely hot and dense and was stretching. However, since the 1990s, it became no secret that the universe is expanding and doing so at an unbelievable rate. Regardless, the worst that could possibly result from this understanding was shockingly uncovered recently by the most powerful telescope known to man, the James Webb Space Telescope. And this recent discovery about the universe could very well mean that the end of humanity is imminent, even closer than the entire space industry could have imagined. So, what exactly is this revelation? Why is it such a shock to the space industry as a whole? On Christmas morning 2021, the world witnessed the latest, greatest telescope successfully launched into space. And for more than a year now, the James Webb Space Telescope, or JWST, has been fully developed and has reached its deep space destination, a remote location 1.5 million kilometers from Earth. Since the time it was deployed, it has produced the deepest and brightest infrared image of the distant cosmos to date, and found multiple galaxies, including those that grew too massive too soon after the Big Bang, hence shattering the Big Bang model of cosmology. In any case, it has produced some incredible findings that have challenged our understanding of the cosmos as a whole. Nevertheless, since the JWST's deployment, many astronomers and scientists have hoped it would contribute to the resolution of the universe's expansion rate, the biggest debate in contemporary astronomy. Since the 1990s, numerous investigations have demonstrated how the universe is quickly expanding, and how the distance between galaxies is now expanding faster than it did billions of years ago. According to many scientists, they theorize that a mysterious force known as dark energy is accelerating the universe's apparent expansion. These researchers underline that dark energy acts as antithesis of gravity, exerting a repellent force that causes the expansion of the cosmos to speed up over time, rather than slow down. The Hubble constant, which is a measure of the universe's rate of expansion, is now centered around the numbers 67 and 73. Each number represents the same quantity, the cosmic expansion rate in kilometers per second for each megaparsec of space, which is approximately 3.26 million light-years. Although these numbers appear to be small, the difference between them is rather large when compared to the great degree of precision for other cosmological observations. So, to put it simply, something doesn't add up and hasn't been adding up for years now. If you try to measure the current expansion rate, well, there's a variety of techniques that people use, and they tend to get a certain number. And it turns out that those numbers don't match, says Tommaso True, an astrophysicist at the University of California, Los Angeles. For years, astronomers and scientists from all around the world have been baffled as to how to explain this disparity, which they refer to as the Hubble tension. If not fully understood, these disparities could cause problems for our current knowledge of physics and force theorists to reevaluate or perhaps abandon some of their most beloved theories. In any case, since the James Webb Space Telescope was such a technological advance over its predecessor, the renowned Hubble Space Telescope, many astronomers felt confident that a more accurate estimate of the Earth's expansion rate could be easily determined because its data would aid in their search and models. However, while they expected to find out more about the expansion of the universe, the JWST discovered something else. A rather shocking discovery. It discovered that the universe has stopped expanding, shattering preconceived notions and redefining entire fields of knowledge about the universe. And this knowledge now presents astronomers with an entire space industry with an unsettling problem. Not just the halt in expansion, but also the nature of dark energy. According to Frank Wilczek, a Nobel laureate from the Massachusetts Institute of Technology, dark energy is the most mysterious fact in all of physical science, the fact with the greatest potential to rock the foundations. The properties of dark energy remain largely unknown, and for many years, scientists including Albert Einstein have theorized that it is a cosmological constant force, meaning that it's an unchanging form of energy that's woven into the fabric of space-time, and as a result, the universe could very well expand and accelerate forever. However, shocking revelations have now shown that that isn't the case. Dark energy makes up approximately 70% of the total mass energy of the universe, And while many scientists have believed due to the observation that it's a cosmological constant, a recent revelation explained that dark energy doesn't need to be constant to fit with observations of past cosmic expansion. In a paper written by 3 scientists, R.R. Caldwell, Raoul Dave, and Paul J. Steinhardt, titled Cosmological Imprint of an Energy Component with General Equation of State, these scientists stress that dark energy may not be constant after all, as it is made up of an entity called the quintessence, which can decay over time. These scientists explain that unlike the cosmological constant, quintessence can either be repulsive or attractive, based on the balance between its kinetic and potential energy at any particular moment. And they have the last 14 billion years to support their arguments, as quintessence has been repulsive ever since the Big Bang. In comparison to radiation and matter, quintessence played a relatively small role in the expansion of the cosmos during that time, according to Steinhardt. All of that, however, unexpectedly changed 5 billion years ago, when quintessence took over as the dominant element and its gravitational repulsion effect accelerated the expansion of the universe. And now it might very well allow the cosmos to shrink until it is compressed into a single entity, in what is known as the Big Crunch, as opposed to the Big Bang that caused the universe to be created. The concept of the Big Crunch has been around for a while. The hypothetical scenario of the universe's ultimate fate dates back to 1922, when Russian physicist Alexander Friedmann developed a set of equations demonstrating how the universe's end depends on its density. The entire premise is that the universe initially expands and then contracts, ultimately bringing the cosmic scale factor to 0. This eventual occurrence could be followed by a reformation of the cosmos, beginning with another Big Bang. It was believed that with enough matter, gravity could stop the universe's expansion and eventually reverse it. This reversal would result in the universe collapsing on itself, not too dissimilar to a black hole. According to the theory, the Big Crunch would be loaded with high-energy particles and star radiation that, when condensed and blue-shifted to higher energies, would be powerful enough to ignite the surfaces of stars before they collided. It goes on to explain that at the very end, neither time nor space would exist because the universe would have collapsed into a single enormous fireball with an infinitely high temperature. It's interesting to note that this entire worldview even dates far back to the Bentley's paradox, a query posed by churchman and scholar Richard Bentley in advance of a presentation on Newton's theories and the rejection of atheism, which raised similar concerns. If we're in a finite universe and all stars attract each other together, would they not all collapse to a singular point? And if we're in an infinite universe with infinite stars, would infinite forces in every direction not affect all of those stars? Bentley wrote to Sir Isaac Newton. Fortunately, we now have solid evidence that stars aren't static, they actually move, hence disproving Bentley's question. However, for many years, this hypothesis has persisted, even though it's all been theoretical and largely speculation, at least until now, as data received from James Webb Space Telescope gives credence to this hypothesis. According to data received from James Webb Space Telescope, it's believed that even though the expansion of the universe has been accelerating for billions of years, the repelling power of dark energy may be waning, and the anti-gravitational property of dark energy is fast dissipating. If dark energy is quintessence, its push on the expansion could slowly wither or disappear, or could even reverse to become an attractive force, causing the universe to collapse into a big crunch. Sean Carroll, a theoretical physicist at the California Institute of Technology in Pasadena, said this. In any case, in a bid to understand the data sent by the James Webb Space Telescope, a team of scientists created a physical model of quintessence to predict how the properties of quintessence could change over the next several billion years, as well as how long it might take the universe to slow down, stop, start contracting, and eventually reach a single point. To their surprise, dark energy in their model can decay with time. Its strength can weaken, and if it does so in a certain way, then eventually the anti-gravitational property of dark energy goes away and it transitions back into something that's more like ordinary matter. Gary Hinshaw, a professor of physics and astronomy at the University of British Columbia, who was not involved in the study, said. More shockingly, the model suggested that the dark energy's repulsive force may be going through a rapid fall that may have started billions of years ago. In this scenario, the accelerated expansion of the universe is already slowing down and may stop expanding at all within the next 65 million years. Then, within the next 100 million years, dark energy may start to become attractive, causing the universe as a whole to begin contracting. In other words, after almost 14 billion years of expansion, space might begin to contract, resulting in the rebirth of time and space. Interestingly, Steinhardt's model predicts that it would take a few billion years for the universe to shrink to around half its current size. He also pointed out that the contraction would be so gradual that any hypothetical humans currently living on Earth would not even notice a change. Steinhardt has made great strides in astronomy and astrophysics. He not only contributed to the development of inflationary cosmology, but also gained widespread acclaim for his studies on the impact of gravity waves on cosmic background radiation, and the most recent discovery of quasi-crystals. And as such, his theories are to be taken seriously. Despite the vote of confidence, the universe is still contracting, and it's unclear whether the team's model can definitively predict how quickly it will contract. These changes, as noted by Steinhardt, haven't yet been detected, and many researchers have come to believe that the scenario is not far-fetched and it fits naturally with current theories of cyclic cosmology. This implies that there might be cause for concern because it ultimately means the end of our universe. Steinhardt asserts that there are a few possible outcomes, one of which is that either the universe shrinks until it bursts into a great crunch, terminating space and time as we know it, or the universe shrinks just enough to reach a condition resembling this initial one, and another Big Bang or Big Bounce takes place, forming a new universe from the ruins of the previous one. According to the second scenario, Steinhardt goes on to describe how the cosmos undergoes cyclical patterns of expression and contraction, crunches and bounces, which cause it to continually collapse and be recreated. And if that's the case, then our present world might merely be the most recent of an infinite series of universes that have grown and contracted before ours, rather than being the first or only universe. These discoveries, despite the estimate that they will occur billions of years from now, are more terrifying to many astronomers and scientists, because despite the impressive models created from the data sent by the James Webb Space Telescope, the most powerful telescope the world has ever seen, we still can't see evidence of it taking place. Curiously, we could not detect the oncoming dramatic cosmic events given the best available observations today, Cosmin André, a physician from Princeton University, said. And the reason is that all the evidence comes from distant objects that emitted light many billions of years ago, such as supernovas and the cosmic microwave background, which is an echo of the Big Bang itself and James Webb. Despite its power, it's unable to capture them. Then it just might be sooner than we think. There can be only one interpretation of the premise that the cosmos has ceased expanding, that gravity would dominate the universe, pulling it out into the universe's center of gravity, and after a few millennia, the universe would be compressed into a very small size, growing denser and hotter until it eventually collapsed into itself and became a black hole, inevitably bringing about the extinction of humanity. And knowing that there is nothing we can do about it, that's terrifying for all of humanity.